Coach Jay, how's it going? This is section 4.5 to 4.8 review for test number 2 of our year. Hope you're having a fantastic day. And, I hope you saw that go airball, but we'll get it next time. We're just having a Gucci day here with 0 viewers. I know there's a lot of people from Sweden over there. There's 1 viewer. Congratulations. You are our first guest. Thank you for joining. And if you do have any questions, you can just post them right over there on the sideboard of the YouTube video. Feel free, check us out and throw some questions up there. I know that this should be very entertaining, and I'm just putting it on this side. I'm putting a little Gucci action on that side. Holla. There we are. Gucci, holla. Put them up there if you got any questions, and we will get this thing rocking and rolling. Okay. Put that right over there and put this here. I did tell someone that I would start with my there we go. Pull this up. I'm going to start with my questions off of 4.8. So we'll address the 4.8 questions here as this comes up. And now I have no viewers. So thank you very much. Appreciate y'all. And no viewers. This is fun. I really feel self-conscious right now. Just joking. Throw those questions out there, but I'm going to start first with these 2. And then we'll get to the other ones here in just a bit. Okay, let's get it going. So first thing is this top navigation problem. I'd forgotten to mention this within my classes. One of the things that you need to note is this 52 degrees here. The same thing as 52 degrees would be, I don't want to make sure. Well, let's do this. Let's draw it first. An airplane is flying at 600 miles per hour, okay? So here it is. There it is right here on this side. There's those little fins, right? And there's its big ones right here and here, okay? All right, it's going over here at 600 miles per hour, okay? All right, and it has a bearing of 52 degrees, okay? And after flying for an hour and a half, how far north and how far east will the plane have traveled from its departure? Well, instead of putting it down there, let's start right here, okay? On the center side, 52 degrees is the same as saying, and really this is what you'll see on the test, so that's why I'm giving it to you. North 38 degrees west. So we're going to go north 38 degrees to the west side, okay? So 38 degrees will fall right in here, okay? So this is where the plane is traveling. It is traveling at 600 miles per hour. But here's the deal. We're trying to figure out how far north and how far east. Actually, backtrack. I just messed up. I'm sorry. Back. I'm sorry. The same thing as 52 degrees. Normally, we don't write it down this way. My fault. It's northwest, and it's really north 28 degrees. 38 degrees. I'm sorry. 38 degrees west. So I'm sorry. Oh, should I just started this podcast over? My fault. North 38 degrees east. If you could just throw this out and start from here, you're fine, okay? So we've got northeast coming, okay? Here's the 38 degrees. And then we're just going to take it from there, okay? All right, just take it from here. So what we're going to do is we're going to take this and we're going to figure this out in terms of how far north and how far east this has traveled, okay? Now, if this is 38 degrees, we could assume that this right here on the inside would be 52 degrees, okay? Again, from this top side, this may be different on the answer key, so if you're watching this, just a heads up. I think I threw it down wrong. My big thing is if I gave you this bearing, which I will, like I did today in class, can you do it from there? So that's what we're looking at. So coming here, if this is 600 miles per hour on this line that it's traveling, and it travels for an hour and a half, that's the key. So how does an hour and a half come into play with 600 miles per hour? Well, if I travel 600 miles per hour, right, and let's say I go for an hour, then I would multiply that together to get 600 miles that I would travel in that 1 hour, right? But let's say that I did 1.5 in that description. We would do 1.5 times 600. And when I do that, I would get a total of 900. So really, this is not 900 miles per hour. We're talking in terms of miles. So we're going to say that this is 900 miles here, okay? So if this is 900 miles and this is north, we're trying to find what north and what east is. So we're going to say that this is y and this is x. So we're going to say something of 52 degrees. So let's do sine and cosine. So let's say the sine of 52 degrees equals opposite, which is y, over hypotenuse, which is 900, okay? So we're going to write that down there. What we do for sine for y, we're going to do that for cosine. So actually, let's just do the sine first because we can just change the cosine around and we'll be good. So 900 on both sides, we'd multiply and cancel. Make sure your calculator's in degree mode. Let me check mine, make sure mine's in degree mode. It is. So we would do 900 sine of 52, okay? And when I do that, my y value would be a total of 709.21. So this is 709.21 miles north, okay? Now I'll do the same thing because if you did cosine, right, you would do 900 over x, right? And that would equal cosine of, sorry, I'm putting it over here, cosine of 52 I'm sorry, this should be x over 900. Sorry about that. Because it's adjacent, which is here, over hypotenuse, right? So x over 900, multiply by 900 on both sides. Make sure we put the 900 in front of cosine of 52. So 900 cosine of 52 equals 554.10. So 554.10 would be the miles that we would travel on the x, or the miles we would travel east. So this is east, and this one is north, okay? Is north. All right, if y'all have questions on that, throw those out there. Sorry, I kind of stumbled through that a little bit, trying to get that bearing down there, but hopefully that makes sense. If you do have any other questions, throw them out there, because again, we'll go through those together. But let's do this last one over here on this side. Hopefully this one is a little smoother. I don't think this one's a bearing here. But it does say that there's a sonar of a Navy cruiser detects a submarine that is 400 feet from the cruiser. That's from here to here, right? Also, the angle between the waterline and the submarine is 34 degrees. How deep is the submarine? So we could actually just find this vertical distance here. So we got 90 degrees here. This one's a little bit easier because we've got hypotenuse on this side, right? We've got our angle right here. Really, that would be the angle of depression. You might say, well, Coach, what I thought that wasn't inside the triangle. Well, in this case, it is, because as it's going here, right, the depression as it looks down, that's the angle connected there, right? The one today on the plane, right, that we used, as it looks down, here's the person right here, right? Here's the angle of elevation here, because it's Coach J, all 6 foot of them, looking up on that side. No laughs, please. I hear those. And then this right here would be the angle of depression, which would be right inside of that area there, okay? So elevation and depression. This one right here is a depression angle as it connects to the horizontal line that it's traveling on, okay? So in finding what this y is on this side, okay, what we're going to do here, you want to say hey to everybody? Hey, right here, sorry, just real quick. We're going to find this just a second. Hey, Emmy, you want to say hi? Come here. Did you sneak in? Did Mommy let you sneak in? Did Mommy let you sneak into the podcast? Can you wave? Say hi. Can you blow kisses? Say, can you blow kisses? Come here. You want to come up here? Do you want to come and do the podcast with Daddy? Yeah. Say, can you say, I'm sorry for interrupting your podcast to the 4 viewers? Yeah, this right here, this is the pad we write on. Yep. Okay. Let's see how long you can last. Probably like 3 minutes, maybe not even. Okay. So what we'll do now is in creating this, let's pull this up. Okay. So what we're going to do now is in solving for the distance or the height of this, we'll just label that y or x. Since we have the hypotenuse and this is the opposite side, we would say, that's 34, right? So we would say opposite over hypotenuse. So the sine, yeah, the sine of 34 degrees equals opposite, which is our y, over our hypotenuse, which is 4,000. Okay, we're going to multiply by 4,000 on both sides. And when we do that, we would get 4,000 sine of 34. Okay, 4,000 sine of 34. All right. Do you want to write on there? While I put this in my calculator. Oh my. Here, do this right up here. Right on it. So 4,000 sine of 34 would end up being 2,236.77. 2,236.77, and that would be our answer there. Okay. All right, nicely done. We're gonna get to well, if Emmy, here go Emsters. All right, let's go to the next one. Let's see if there's any questions out here. I don't see any other questions, but what we can do is start going right straight to our review. Okay, here you go, mommy. Come here. All right, so what we're going to do here is start on some of the review questions. I'm going to refrain from trying to do any of the ones that we've kind of already have done. So like if you look here, like that one, right? We could do that one pretty easily, probably, right? Those two we'll probably stop on. I'm just going to start going down the list and hitting the process. If you have any specific ones, please throw them out there. I see 4 viewers here. So if you do have any questions, throw them out there. So number 3, we see that the angle A is linked opposite of side A, side C and angle C, side B right here, and angle B, right? We see that the 90 degrees is the angle C, and we then note that because this is the 90-degree angle, side C is the hypotenuse, which a way that we could check this is it's always the larger side, okay? Always the larger side. So we're going to say that A being 38 degrees and C being 15. So if I put 15 here, right? And A was 38 degrees right here, right? What we can do on this is try to figure out what are the other angles. Well, B in this example, we could solve by taking 180 minus 90 minus 38, right, to get angle B. And then afterwards, we would use SOHCAHTOA to kind of solve from there, okay? SOHCAHTOA, okay? Now, the one that I really want to hit on is number 4, because this one, again, it gives you a triangle up here, but it doesn't really matter where your triangle is. So if this is angle C, this is side C, angle B, side B, and angle A, side A, okay? All right, so here we are. We see that side A is 11, side B is 15, but we don't know anything else. We need to find another angle. Well, side C we could find pretty easy because we could just do 11 squared plus 15 squared equals, and then we just say C squared. So we'll just kind of do this in our calculator here. Calculator. So 121 plus 15 squared. And we take the square root of that 346. Let's see if that goes evenly here. I don't know if it does or not. It doesn't. So this would be C is equal to, right, the square root of 346. If I were to simplify this, I would say, okay, 346 divided by 4. Let's divide that by 2. 346 divided by 2. 173. I don't think that goes in anything. Let's see. 173 divided by 7. Nothing. I don't think it goes into anything. I could be wrong. Let's see, 173 divided by 13. Nothing. Okay, so because of that, we would just say the square root of 346 goes in for C, which is fine. Okay, so the question is, how do I solve for angle B and angle A? And to do this one a little bit differently, we're going to come down here. So in solving for angle A, we're going to solve for angle A by saying the tangent of A equals the opposite, okay, so this case it's 11, over the adjacent, so opposite over adjacent, which should be here. So how do I get tangent and A out of there? Well, to get rid of it, we take the inverse of it, right? To get it gone like a freight train, gone like yesterday, gone like a home I had a Once I do that, I do the tan inverse of 11 divided by 15. And what we do is we get 36.25 degrees right there. 36.25 degrees for A, and then we could subtract that from 180 to get to angle B there, okay? I still have not gotten any questions on that. That doesn't mean that y'all are wrong, but I'm just going to keep rolling through some of these. So I've gone through 1 through 4 here. I want to go to the next one. This is where it starts getting a little bit tricky. Number 6 is a really good one. Man, number 5 is a good one. Star number 5, star number 6. I already went through one like this one, right? I already did this one here. What's nice is you see kind of the bearing I was talking about. So the bearing is going to be given to you, but this one's very similar to the one that was on the homework and one that might be on the test. So just a heads up on that. But let's do number 5 and 6, and we can always come back to the other ones. Notice the inside arc sine of x minus 1. Well, I can't cancel out this cosine and arc sine largely because they're not the same, right? Now, if they were the same with one being inverse or arc sine and the other being the regular, we could. But in here, we're trying to find what is the arc sine or the angle that's given of x minus 1. So let's say theta's here, and x minus 1 follows the sine, so we can assume that it's x minus 1 over 1, right? Or opposite over the hypotenuse, okay? So in doing this, we have the opposite over the hypotenuse here. We can say the opposite is x minus 1. And the hypotenuse is 1. So now we've got to solve for the adjacent. Remember, I hug, right? Adjacent side. So we're going to say the a squared plus the x minus 1 squared equals 1 squared. Or 1 squared is just 1, right? So let's get a by itself by saying a squared equals 1 minus x minus 1 squared, and we'll just leave it at that. So once we simplify, let's simplify this right side here to be 1 minus, and then now we're going to distribute, right? So this is x minus 1 times x minus 1, just a heads up. So this would be x minus 1. I actually want to show you this because I think people will mess up if I don't, okay? So this would be x squared. Don't bring the negative in yet. Don't bring this in yet. X squared, distribute, minus x plus 1, right? And this is 1 minus this. So this sign's going to change. This one's going to change. This one's going to change. And so will that one, okay? So we're going to literally change each one of these. So what we've got now is a squared equals, well, we can square root all this and just simplify, okay? So we've got 1 minus 1, we could cancel. And I've got negative. So I've got the square root of negative x squared plus 2x. Now, I can't really do anything with this. This is as simple as it's going to go. So we're just going to put that as our adjacent side. So once I'll keep it in here. By the way, the square root can't take out of that square there. The only time a square root and a squared could cancel is if the whole thing See how this whole thing's in parentheses squared? Then I could, right? But over here, I cannot. So because of that, I would say, what is the cosine of this triangle? I would say the adjacent side would be the square root of negative x squared plus 2x. And it's all over the hypotenuse, which is 1, right? So we would just say that this would be our expression for the cosine of that, okay? Gotcha. Still no questions on that? I'm just going to throw down questions with a question mark just so that we're here. Let's see if there's any more. Still 4 out there. Appreciate y'all showing up. Y'all are awesome. So thank you so much. Y'all make my day there. All righty. Let's go to number 6. This one is different, okay? What I'd like to do is just talk over a couple things. Let's talk about the amplitude. Let's talk about the period. I want to do the ones we traditionally do and then just show you how this could be different, right? Phase shift. Okay. And the last one is amplitude and then center line. Okay. Now, once we solve this, let's talk about the first thing. Amplitude's the number in front of sine. We know that that would be 4, right? That would be 4 there. The period is the value that is 2 pi over b. And oh, by the way, you're going to have to know those, okay? That's going to be big time. Please make sure you know those, okay? I gave those to you on the quiz, but please know them. B is 3, okay? So really the value of that is 2 pi over 3. Okay, the period is 2 pi over 3. Phase shift is C over B. So we're going to put that down where it's going to be pi over 4. And then that will be all over 3 over 1. Okay, so I flip the flippy to 1 over 3. Multiplied by pi over 4, and that expression should be, or the phase shift should be, pi over 12, okay? And by the way, the sign's huge here. I like how Chris does it. We're doing negative c over b where you plug in kind of the sign. If this is negative here, I can assume that this is going to go to the right. So you can either put a positive, you could put an r for right, or if it was going left, you could put a negative and so on and so forth. The one thing that I did want to hit on, and I don't think it even says to graph it, so you're good there. But the one thing I want to hit on is, what is the center line, right? Well, you remember that in a sine graph, the highest and lowest value is the amplitude, right? 4 and negative 4. But the center line, the vertical shift, changes with a negative 1. So this would actually go down 1 to 3, and this would go down to negative 5. So because of this vertical shift, it literally moved everything down 1. And it also moved this 0, which was at 0, down 1. So what we would say is the center line is at negative 1. The value that's in the middle between the highest amplitude and the lowest, that's where it's at. And it just so happens that it's actually we call it vertical shift. You could put that down too. I would take that. But both of those would be sufficient. But it would both be negative 1. Okay? All righty. Nicely done. We're rolling through this review here. Let's keep rolling. Okay, let's keep going. Actually, this one we already did. Wow, we are going. Okay, yes. Okay, let's talk about graphing. Let's do a graphing one here. Heads up, make sure on this one, same idea. Number 7 is very similar. And in fact, did I mess up on that last one? I want to make sure I didn't. Yeah, that's sine. Okay, we're good. Just remember with secant, you would graph it using cosine, right? And then the difference is remember the dotted lines through the x-intercepts. We'll do one there. In fact, we'll do number 11 here. But just a heads up on that one. I will come back to numbers 8 and 9, do that on the podcast. We should have plenty of time for that. Really, any of these expressions like right here, right here. All of these ones, please just make sure you know how to do it. All the graphing ones, like if you need more practice on that, go back to other problems. I'm telling you, there's plenty of problems out there for you to practice. So please, please, for that part one, practice, practice, practice there, okay? All graphing, or like number 7 where you have to find the values and that sort of thing, okay? All right, hopefully y'all, you'll be able to see this here. What I'm gonna do is I'm gonna just draw this out. Let's find number 11, the amplitude, the period, and the phase shift, okay? And there's actually a vertical shift too, so we're gonna put that here. Or again, remember we could call it the center line. So let's actually graph these and see if we can solve these here. So first thing is the amplitude is 1. I would also take -1. Sometimes I'll put an R out here telling myself that this is reflected just to give myself a heads up on that, okay? Because of the negative, what was up would start now down. The next part is the period. Remember the period being 2 pi over b, where b is the value of 1. So we would say 2 pi is the period. 2 pi is the period of the cosecant. The phase shift is now a little different. The phase shift will end up being c over b. So it would be the pi value over 2. And because this is a positive on the inside, we would say it actually starts at negative pi over 2. So we're going to put right here, negative pi over 2. And we'll make this 0 just to help us out, okay? So we got the phase shift, we got the period, we got the amplitude. We know the amplitude traditionally goes up 1 and down 1. But because of the vertical shift of +2, this center line would not be at 0 now. Now this is going to be up 2. This is going to go up 2 to 3. This would go up 2 to +1. Okay? So now, if I start at negative pi over 2 and I travel a distance of 2 pi, okay, not 2 pi, 2 pi, I will literally add 2 pi to negative pi over 2. Okay, so if you need to do that, here's the period. I add that to negative pi over 2. I'll put a 2 on the bottom. Multiply 2 on the top to get 4. So 4 pi over 2 minus pi over 2 gets me to 3 pi over 2. Okay. So what we'll do is, and again, this is just how I count. Each one of these is going to be pi over 2 just to make it consistent. So you got pi over 2, 2 pi over 2, which is right here, right? Okay. Did I do that right? Just want to make sure. Yeah. So this is 2 pi over 2, which is just pi, right? This would be 3 pi over 2. And we'd be good to go. So this is my ending. This would be my middle. These are my quarters here and here. Okay. With cosecant, what I'll do is just to give you a heads up so I can kind of do it. So I'll just keep doing my thing. I'm going to do another period. So it kind of, as you could see, it kind of keeps going between pi over 2, pi over 2, 3 pi over 2, like adds 2, right? 2. This would be like 5 pi over 2, right? Next one would be 7 pi over 2. Okay, so once I graph this, right, the cosecant graph is starting at sine. And what that means is I'm going to start by going downward because of the negative, right? So it's going to go down, 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 low, low, low. And then as you do this, okay, you're going to go downward. As you do it, you have to sing the song. You ready? She wore the maple bottom jeans, boots with the fur. The whole club was looking at her. It's because we were going down first. Did you know this? Notice that? Okay. Just want to make sure you're all clear. Okay. Sorry. Wow, that's a great graph, right? Okay, so there's my graph, period 1, period 2, got them labeled. But because it's cosecant, we're going to go here, 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 and here. And then what I'm going to do is with another color, come around, come here, down here, here, and down here. And there you are. There it is. There's the cosecant graph. You're good to go. You're Gucci. And we're good. Awesome. Can we graph a cotangent? Oh, yes. Great call. Great call. Okay, let's graph a cotangent one. By the way, that looks awesome, doesn't it? The colors just makes me so happy. Okay, some of these also we can do later on as well. Ones like 8 and 9. I think we're hitting 8 and 9. And a lot of those types of problems tomorrow too. Okay, there's a tangent. Okay, here's what I'm going to do. I'm going to take this tangent and change it to cotangent and show you the difference between the two, okay? So we're going to say -5 cotangent of x minus pi over 4 and we're just going to leave it as that, okay? Now remember that when we solve for this, we find three things, right? And I'll actually throw this down right here. There's two asymptotes and an amplitude that I solve for. So the first thing I want to do is say the amplitude would be 5. And you could put a little r there because we know it's reflected because of this negative sign on the front. Meaning that if you go tangent, cotangent, right? The cotangent graph would end up being the tangent graph, right? Tangent graph. So as I look at x minus pi over 4, this is where the other ones come into play, okay? We bring, oh, I'm sorry. I'm actually doing this on purpose now. I'm just telling you. I'm being a rebel. Feels so good to be a rebel. Okay, so we're gonna take x minus pi over 4, okay? And we're gonna do a little bit with both of these. We're gonna have two of them, right? And the first one we've got is we're gonna set, because it's cotangent, we're gonna set the first one equal to 0 and the second one equal to pi. Okay? So in both of these cases, we're gonna add pi over 4. And again, while I do that, it's taking a little bit here. The easy part is that when we do a pi over 4 with 0, we know the answer will actually just be pi over 4. So we're just going to hold on to that. That's the answer there. Also, we can put this amplitude at 5 and -5 here, just a heads up. So the next part is we're going to add pi over 4. Now, this is good to know as I write this. If this was tangent, what would we do? Well, we would actually take the same thing, except now we wouldn't set it equal to 0 and pi. We would set it equal to pi over 2 and -pi over 2. So just a heads up on that. Little different. So if I include a 4 up on top and a 4 on the bottom, I'd say 4 pi over 4 plus pi over 4, and that would end up being 5 pi over 4. Okay? So we got 5 pi over 4 and pi over 4. Let's add by pi over 4s, okay? So there's 1 pi over 4. There's 2, there's 3, there's 4, there's 5 pi over 4, right? That's where we're stopping. That's what it said. Okay? We won't label it quite yet. But we have this. We got this one. We know the middle is like right here. So that's 1, 2, 3 pi over 4. All I need is the beginning, middle, and end. Since it's tangent, cotangent, with a negative cotangent, we normally would rise left and fall right with positive. Now we're going to rise to the right, and at the quarter spots, right here and here, I'm going to rise to the right. Falcons rise up with the falcon colors there. They actually asked me to sing that song, but I told them that I was too busy with y'all. So there you go. Yeah, Dorian Parker, they wanted me to do Broadway too, but they just I just told them, I said, look, I'm busy. I've got these kids I've got to deal with, like I've got to do this. Like I love these kids is what I told them. I can't do Wicked. I just can't do it. And they understood. They understood where I was coming from. You know what I mean? The only thing that I would say is if this is 5 pi over 4, that's 6 pi, make sure you label this as 7 pi over 4. 8 and then 9 pi over 4. Okay. Yeah, hopefully that helped on how you set it equal. Again, the only difference is if you see anything here following tangent, you would set it equal to pi over 2 and -pi over 2. Same thing here. Look right here. Pauline, I hope that makes sense. But here, you would set this equal to pi over 2 and negative pi over 2. Okay? And that's how we would do it there and to find those on that side, okay? Good, good. Hopefully that makes sense there. I did want to do, yeah, let's do number 13. Let's do one of 13s. Man, I think we're hitting this pretty good today, actually. Pretty happy with how we've gone. Thank you all so much for, again, showing up here. Let's look at 13a. This one, just like the one before, the only difference is that arc sine of 3 over 7 I can't find on my unit circle, right? If you look over on this side, I think, yeah, right here, you'll notice that on this one, as I cancel, right, because they're the same exact thing, my answer would be negative square root of 3 over 2, okay? Now, please, please, please do not do this. Don't just cancel these, okay, and say, oh, that's 7 pi over 6. When I get an angle, that's when it's a little different because we know 7 pi over 6 is over here. That's trespassing because we remember my story. This right here, my friend named Billy, my imaginary friend. First and fourth quadrant is where we're at. Since we're talking about sine is negative down here. Where is sine also negative? Sine is negative in the fourth quadrant. In order to get to it, we go backwards. So instead of saying 7 pi over 6, we would say, oh, the same location is negative pi over 6. Okay? Now, with that being said, this one, 3 over 7, cannot be found on my unit circle. And they're not the same, so I can't cancel. So I would say that this is similar to, let me go back here because hopefully this will help you. I don't, this, oh, one is it? Oh, right here, number 5. Very similar to number 5, okay? In fact, this one's, I think it's easier, okay? So if this is theta, the angle, 3 over 7 is opposite over hypotenuse because we're talking in terms of sine, right? The angle with sine. We don't care about the angle at this point because we remember that tangent is coming in and going to save the day, and we're going to need that. So we're going to say 3 is opposite, 7's hypotenuse. So we would say A is what we're looking for. So 3 squared plus A squared equals 7 squared. So we say 9 plus A squared equals 49. I would subtract 9, take the square root of both sides, and I would get the square root of 40. Okay, square root of 40. Now, this also is in quadrant 1 because it's positive. Even though I put it over here, I should have drawn the triangle this way because it's really in quadrant 1, right? So this should be 3 and this should be 7, the adjacent. But that'll work. This right here could be broken down into 4 and 10. This could be 2 and 2, right? I'm just doing the little tree method. 10 is 2 and 5. Are there any pairs? There sure are. We would take a 2 on the outside and be left with 5 times 2, which is 10. So we would say that A is 2 root 10. Okay? So as I check that out, tangent is now opposite over adjacent, or we would say 3 over 2 root 10, where we would multiply by root 10 both top and bottom here. To get 3 root 10, this is 3 root 10, over 2 times 10, which would be 20, and you would leave that as is, okay? That would be the ratio, right? Yeah, okay? Oh, yeah. Good question. Yeah, I put number 13. You do not have to do that one on there for the actual test. You're right. Thank you, Deanna. 13, just a heads up, do not have to do, but the process will help you in getting a rep out for this one, because this one you could write that in. That one's going to be on there, or one similar. Okay. Good question. Thank you, Deanna, for helping out with that. I really appreciate that. Nicely done. All right. So with that being said, I hope you had a phenomenal time. This was Coach Jay signing out. And before I do, My traditional throwback. Here we go. Never made it. Yes! I did it! Yeah! I did it! I've never done it on a podcast before. Completely live. Get your world. Yeah! That's what I'm talking about. I'm gonna dunk. I'm gonna dunk. That's what I'm gonna do. Yeah! That's what I'm talking about. You just saw it. All three of you. You just saw me make it. Oh, it's a great day. It's a great day to be alive. I hope you have a great day. Man, I just can't top that. I'm going to bed. I just can't. I mean, I could stay up, but I'm not going to top that. I'm just telling you right now. Tomorrow in class, we're going to go over a lot of the inverse stuff. So come ready because the inverse stuff is definitely on the test, and we want to hit that. So come in, we'll see it, and we'll go from there. And my daughter's coming by to say bye. Can you say bye? Oh, look at it. Hey, Daddy hit a good shot. What you think about that? What you doing, coloring? Are you coloring? Hey, signing out, y'all. Have a good night. See ya.